Hi guys, welcome to another lesson. Today's lesson focuses on analytical geometry. So in the given diagram we are given 4 points A, B, C, A, B, E and C, and they also tell us that C is the midpoint of AB. So C here is the midpoint of this line AB. Also F is such that AF is equals to FB. So these two lines are equal in length. And they also tell us that AF is perpendicular to FB. So these two lines are perpendicular. So the first question says determine the length of AE. So AE is this line segment. So we need to apply the distance formula. So you'll notice that XA and YA correspond to 1 and 3. I use the subscripts for the letter A, and XE and YE correspond to -2 and -1. These coordinates represent E. So now let's apply the distance formula. Distance AE is equals to the square root of XE minus XA squared plus YE minus YA. So this is equals to the square root of XE, which is -2 minus XA, which is 1 squared, plus YE minus 1 minus 3 the whole squared. This is all equals to -3 squared plus -4 squared, which is equals to square root. -3 squared is 9 plus -4 squared is 16, which is equals to the square root of 25, which is equals to 5 units. So AE is equals to 5 units. So the next question wants us to find the gradient of AC. So AC is this line. So we need to use the gradient formula. Notation is important. Small letter M, AC, which is change in Y, YC minus YA over change in X, XC minus XA. So now we can substitute. YC is 1 minus YA, 3. All over XC is 2 minus 1, which is equals to -2. All over 1, which is equals to -2. So the next question wants us to calculate the coordinates of B. But you will recall that C is the midpoint of AB. So then XC becomes the average of A and B. So algebraically it looks like this. XC is equals to XA plus XB all over 2. But we have XC to be 2. So we can say 2 is equals to XA, which is 1 plus XB all over 2. But 2 can be seen as 2 over 1. So now we can cross multiply. So this is 1 plus XB is equals to 4. Therefore, XB should be equals to 3. So the x coordinate of B is 3. And same can be done for the y coordinate. So the y coordinate here, YC is the average of these two coordinates. So we can write that down as, so YC is the average of YA plus YB all over 2. This is equals to YA is 3 plus YB all over 2. But we given YC is 1, but this can be seen as 1 over 1. So now we can cross multiply. So this is 3 plus YB is equals to 2. Therefore YB should be equals to -1. So the coordinates of B is therefore 3 and -1. So So the next question says BE is joined to form a special quadrilateral AFBE. Name the special quadrilateral AFBE. Give full justification for your answer. So to realize this quadrilateral, we need to just join E to B, and already we know that AF is equals to FB, it's given. So if we can somehow prove that AE is equals to EB, then AFBE then becomes a kite, because adjacent sides for a kite are equal. So we know that AF is equals to FB, it's given, and we know that AE is 5 units, so we can just denote that on our sketch. So this here is 5 units. So let's apply the distance formula to find the length of this side. So we can say distance EB is equals to the square root of XB minus XE the whole squared plus YB minus YE the whole squared. So now we can just substitute XB 3 minus XE is minus 2 the whole squared plus YB is negative 1 minus YE, that is negative 1 the whole squared. So this is equals to 3 plus 2 is 5 squared plus minus 1 plus 1 is 0, so this is 0 squared, and 5 squared is 25, and the square root of 25 is 5 units. So it means the distance EB is 5 units. Therefore, AE is equals to AB. This implies that AFBE is a kite, and the reason is adjacent sides are equal. And finally, the last question wants us to find the area of triangle AFB. So on the schematic, we can see that AFB is this triangle. They want us to find the area of this triangle. And we also notice that AFB is a right triangle, so we can employ Pythagoras theorem. We can already find the distance of the hypotenuse by applying the distance formula. So we can say distance AB is equals to the square root of XB minus XA the whole squared plus YB minus YA the whole squared. This is equals to the square root XB is 3 minus 1 the whole squared plus YB minus 1 minus 3 the whole squared. So this is equals to the square root of 2 squared plus minus 4 squared, which is equals to square root of 4 plus 16, which is equals to square root of 20 units. So we can just write that down, that the distance AB is the square root of 20 units. So now we can use Pythagoras theorem to find the missing sides, bearing in mind that these sides are equal. So the first thing we can take note of is that AF is equals to AB. So using Pythagoras theorem, we can say that AB squared, square of the hypotenuse, is equals to sum of the squares of the other two sides. But since AF is equals to AB, we can say this is equals to AF squared plus AF squared. So therefore AB squared should be equals to 2AF squared. And we found AB to be square root of 20, so this is square root of 20 squared plus 2AF squared. So square and square root, therefore 20 should be equals to 2AF squared. Therefore AF squared should be equals to 10. This implies that AF should be equals to the square root of 10 units, and this further implies that AB should also equals to the square root of 10 units. So we can just note that on our diagram as well. So now we can apply the formula for calculating the area of a triangle. We can say that the area is equals to half multiplied by the base times the perpendicular height. So in this given case, we can call this our base, and this here is our perpendicular height. So this is equals to the base, and this is equals to the perpendicular height. So we can just substitute. It is half times the base, which is square root of 10 times square root of 10, which is equals to half times 10, and half of 10 is 5 units squared. Thanks for watching. See you in the next one.